So very good morning to you, everybody. My name's Jamie Pease. I think most of you know me by now. I'm the chair of the security stream for GSE in the UK. Welcome to this next session, and where we've got Rob Scott from Rocket Software, who's back with us to talk about SDSF Security and how it works in zOS 2.5. So as many of you will know, zOS 2.5 is recently out, recently GA. So it's going to be I'm very interested to hear about this on the SDSF security side, things that we need to be thinking about. For the purpose of feedback, this is session 5AB. And I'll give you a reminder at the end of this session to do that. But if you do complete it during the session or after the session, one thing I need to draw your attention to, the first question, question 1, 5 is the best answer rather than 9. And so just keep that in mind. It sometimes confuses people. This session is being recorded, by the way, so if you have to drop off, then you can listen to playback when these sessions are made available for replay. If you have any questions, please do pop your questions in the chat or raise your hand. And then we do have the option as well to unmute your line if you'd like to speak to Rob directly. That's not a problem. But yeah, we really encourage you to ask questions, keep it interactive. So without further ado, Rob, so welcome back to the security stream. I know it was when we were able to meet in person when we were at Whittlebury Hall, was it? I think it was 2 years ago. You did a session for us, didn't you, on authorized code and protecting the integrity of the system. So yeah. Welcome back, and the stage is yours, sir.
Okay, thank you very much. Okay, guys, so zOS 2.5 came out end of September. And there's been some quite fundamental changes to the way that we do security. So we thought we'd knock up a presentation to explain what we're doing and actually how SDSF security works in 2.5, because we've gone SAF only. So I'm going to take you through all the SAF considerations that you have to think about, whether it be for just using the product or the more advanced features. Okay. So I'm going to go through a little bit of the background. Some fundamentals. You need the SDSF servers now. It is a mandatory requirement. Go through how you would basically use SDSF from a panel basis. How you perhaps would administer the scope of the data that individual users can access. And then we go on to some more advanced functions, operator commands, destination authority, and things like that. And then at the end, there's a little bit about using the actual SDSF product itself to understand how the security is set out, and even tracing your security requests as you use the product. Okay. So historically, SDSF, it's been around since the 1980s, and it originally was shipped with its own internal security methods, tables, and declarations within an old loader module called ISF Palms. And then once we brought the SDSF server out, some of those statements were inherited by the ISF PRM Palmlib member. But obviously the developers back in the early 1990s realized that SAF was the way to go. So SDSF SAF security was implemented then. And IBM have been strongly advising customers to migrate to SDSF SAF security for at least 25 years. However, the product has always supported the concept of a fallback to the old legacy internal security. So the way that the logic works is that we attempt, first of all, in 2.4 and below, to do a SAF security check on the thing that you're trying to do. And if we get a no decision back from SAF, if SAF still says, no, I don't know anything about it, I'm going to give you a return code 4, we fall back to internal security, and that is based on definitions within ISF PRM-XX or the old ISF Palms load module. But from 2.5 onwards, all security checks are now performed by SAF, and we do not fall back to ISF Palms on the client side. So the advantage of this is a single security administration and audit functions, We're using industry standard ESM functions. So, we're standardizing on SAF. We have been warning about this, as I said, for about 20 odd years, but now we've actually pulled the trigger. So we do currently in 2.5 use ISF palms sort of. So we will load on the server side and the version of ISF palms that exists, and we will use this as emergency fallback in case the server cannot initially activate due to an ISF PRM XX failure. But on the client side, that does not occur anymore. So the only people who can use SDSF when we've fallen back to this emergency ISF palms are people, typically systems programmers, who have SAF access to a resource called server.nopalm in the SDSF class, okay? And the idea here being that you can get into the products and you can do a remedy situation to get the server to start properly. So let's go through some of the security fundamentals about the product now. As I said, SDSF security, SAF security is required starting from zOS 2.5. Users who, customers who still are on the legacy internal security, we realize that this is a bit of a migration effort. So we have actually authored a brand new security migration guide, SC 274942. That's available on the 2.4 bookshelf, as well as the 2.5. And also there's a lot of staff information in the operation customization guide. So the SDSF class is used to protect SDSF resources and product functionality. So the typical things are the ability to display certain panels and maybe take actions against objects shown in the row on a panel. But SDSF also performs SAF checks for other things, other classes for resources we don't own. For example, JES-Spool class or the upper commands class. Okay. So one thing that's very, very important to remember here is that we don't own those resources in SDSF. We're doing a check against resources in those classes to make the experience within our product better. So, for example, if you attempt to do an action that generates an operator command, we will see if you've got authority to issue that operator command so that you'll get a nice message back from SDSF to saying not authorized, rather than getting an ICH 408I hate mail and producing a message on the syslog. So it's very important for people to remember that, because sometimes we get confused, customers get confused that it's actually SDSF that is controlling your ability to issue an operator command, and we're not. We're just checking that authority before we let you use our UI to do that thing. Okay. If we do that SAF authority check for JES-Spool or operator commands, we forward the request to the underlying component, be that JES2 or MVS, and it will do its own checks afterwards. But hopefully, by the time it's gone through our UI, it's all going to be well and good. Server address spaces. So as I said before, the server is mandatory from 2.5 onwards, and all the security checks are performed by code in the SDSF server on behalf of the user. It's worth noting here that there's absolutely no need to restart the SDSF server after an IPL unless you're doing some sort of maintenance. Just leave it up. The SDSF server itself owns all the resources. It owns all the authorized code, PC routines, and things like that. There's absolutely no need to stop and restart it overnight. If you want to activate new ISF PRMs, there are dynamic operator commands that you can use to refresh your paths. SDSF AUX, on the other hand, is an auxiliary address space and typically used for data collection. So all our server resident data collection subtasks reside in SDSF AUX. And if for whatever reason you want to stop and restart SDSF AUX, you can do that without restarting the actual SDSF server itself. There are operator commands to do that. You will require some entries in the static class for each of these server address spaces, and an OMVS segment is now required for the user ID associated with SDSF AUX, because we do some zOS Unixy things within that address space now. Fundamentally, also, we need read access to some utility class profiles to gather some of the data that we need. So you're going to need read access to get the WLM policy information in the class, in the facility class, and also RMF data as well from monitor 2. So there's a facility class profile there. Each user that uses SDSF must actually connect to the SDSF server, and if they cannot connect to the server, they cannot use the product. And we restrict this connection to one connection per TCB, per task, because everything is anchored off of your task for things like recovery purposes. So we have a profile that is in the SDSF class that dictates whether or not you can connect to the server, isf.connect.sysname. And as I said before, if you do not have access, read access to that profile, you will not be able to use SDSF at all. Once you actually try to connect to SDSF, it attempts to place you into a logical construct called an SDSF group. In previous releases, that used to be used for some security specifications as well, but in 2.5, it's not really used that way anymore. Most of the time, it's purely just preferences and things like that. But you will need read access to an SDSF class profile group dot name of the group dot sysname, and you will be placed into the first matching group that you have access to. If no matching groups are found throughout all the defined groups, your connection will fail. And as I said before, these groups are really used to dictate options and customization settings. But there are a little exceptions to that rule, and I'll come on to those a little bit later. Okay, so let's think about what happens when you actually try to use SDSF panels. So we've got three styles of user, and we provide sample statements for those in ISF PRM 00 and 01 in SISF JCL, which is like our shipped sample installation data set. So we've got a systems programmer, we've got an operator, and we've got a general user, for example, some sort of COBOL programmer. Okay. So we have, as I said, ISF PRM 00, which is sufficient for most installations to get going. And we have ISF PRM 01, which is all statements provided with their default values. So it's like a full deck of all possible PARM-lib statements. So our panels are set into two distinct groups, those that we think are general user panels, and those that we think are more advanced and more powerful panels, perhaps for systems programmers and operators. All your bog standard Q panels are under the isf command.dsp high-level qualifier profiles in the SDSF class. And so they think of DSP standing for display. So this includes STDAHIO, all those sort of standard SDSF panels, the original commands that was in the product in the 1980s. The systems programmer stuff, not operator stuff, is protected by profiles in ISF cmd.odsp.name.qualifier, and ODSP standing for operator display. So you can deny general users from all of these advanced displays by just giving them no access to isf command.odsp.splat.splat. Okay, and lots of sites do that. And so it means that your bog standard programmer has been seeing the same 5 to 8 choices for the last 30 years, you know, DA, H, IO, etc. But there are now over 60 other panels for systems programmers and operators. And you can actually see, if you do a set menu all in the product, you can show all possible choices. So you get the unauthorized and not applicable choices will show on your main menu. You can see all the panels as well from the display pull down action bar in ISPF. Okay, so once you're on a panel, and each panel's got their own profile to say if you can display it or not. You have rows on that panel, and in the NP column, standing for input column, against the row, you can take actions. And what we do, depending on the action definition, we might do some more security style checks. So typically you will need sort of read access for display style actions, and a higher level of access, update, control, or alter for change or delete style actions. When the action just displays another SDSF panel under the covers, then no security check is made. All we do is make sure you have access to display that underlying panel. So we've used throughout the product JSpool class profiles to protect individual rows on panels. So ST, DA, H, I, and O. There will be read access or a control or alter access for an action taken against a row on that panel. If we know that there's another IBM class that protects that logical construct on the panel, we will make that check as well. And a good example here is for the health checker rows, we will check access to the X-Facilic class profile that covers that object. We also use SDSF class profiles for other panel objects when we're generating operator commands as well. So we'll use ISF XXX dot some sort of qualifier, where the XXX will be some sort of short name that describes the row object. So ISF APF, for example, will cover the rows on the APF panel. And as I said earlier, we always check the operator commands profile if your action generates a zOS operator command. Okay, so that's checked after successful access to the profile covering the row object. So the best way to sort of go through this, I've got 3 examples here of a user trying to do something on various panels within the product. So the first example here, we've got a user Fred. He types H to display the held output queue for the JES2 subsystem called JES2. Fred then issues a P against a JES job ID called bowling on node Bedrock, and the job is owned by a user called Barney. Okay, so because we've got a P action, this is going to require alter access as it's a delete style request. And the row, because it's on the H panel, is protected by a JSpool profile. We are actually going to, underneath the covers, generate an operator command. So we're also going to do a SAF check against the opper commands profile. Okay, so we have a sequence of 3 SAF checks. So first of all, the guy is going to see if he has actually got read access to the H panel. So ISF command.dsp.held.jes2, where jes2 is the subsystem name. So we need read access to that panel to show the panel in the first place. We are then going to do an alter access check for the JSpool profile, bedrock.barney.bowling.jobid, some sort of qualifier. And then, because if that passes, we're going to generate a JES cancel command. The user needs update access for the opper commands profile, jes2.cancel.bat_out. Okay, so to do that simple little B action, we've actually gone through three SAF checks in order to do that. Another example here, user Fred types NA on a system called Wilma to show the network activity, and then types DN beside the row for the TN 3270 job to display the connections. So the DN action requires read as it's a display style request, and the row is protected by an SDSF class profile at this time because there's no underlying IBM one, and we call that ISF netact dot, and there's some qualifiers there. And the D command is going to generate an operator command, so we are still going to check the opper commands profile. So again, the sequence of this SAF checks, read access for ISF command odsp.netact.wilma to show, see if you can go onto that panel. Read access for the SDSF profile that covers the row, that's isfnet.jobname, and read access for the operator commands profile, mvs.display.tcp/ip. Okay, so there's an example there of using an SDSF profile to cover the row that we're showing. Last example of issuing actions. Fred again types CK on Wilma to show the health checks, and then types DS against the ASM local slot usage check to display its status. Okay. So again, DS requires read as it displays style request. Now the row this time is protected by xFacilitate class profile because we know there's a logical profile for that resource. And again, we've got an operator commands profile check because the DS command generates operator command. So once again, we check the display SDSF profile. We then do a read access check for the xFacilitate class profile, and then an update access for the upper commands profile, because that's what health checker requires if you're going to do the modify to the task. Okay. So there's quite a lot going on under the covers as each user does a simple action against the row. Overtyping is similar, but there's a couple of extra things that we do. So an overtype column in SDSF is protected by its own, the column itself is protected by its own class profile, ISFATTR type.column. So if you don't have the correct update authority to that profile, that column will never appear in overtypable form on the screen. So you will not be able to overtype it. So it will just look like a normal output column. So what we do here, the entire updatable column must be visible on the screen. If some of it's off to the left or right hand side, it is marked as a read-only column. So you only see the data that's currently there. If access to that column is allowed, those attributes on the screen are changed to allow you to overtype it, to allow input. And as I said before, if it's denied, the attribute's left for output only. Okay, so if a valid overtype value is detected, what we do then is we drop through as if the user has done an action on P. So we've got the new value, but it's a logical action against the row. So we drop back through to all the previous sequence of checks to see if we've got access to the row, if there's an underlying profile, if there's an operator command, blah, blah, blah. It goes through the same process, but there's a little bit of extra checking that's done to see if you can even overtype that value on the screen.
Rob, just before you move on, there was a question from Darren Smith. He says, is there any documentation I can refer to saying this is a requirement for zOS 2.5?
What, the SDSF Security?
Yeah.
Yes, there was an ICN issued. It's in the manuals, in like bold text.
Okay.
Okay.
Thank you.
Okay, controlling the scope of the data display. So remember when I said that the group statements in ISFPRM are not used for security? Well, this is where there's a slight exception. Okay, so the job name prefix, this basically alters the scope of jobs that you can display on the queue panels in DA, so IH, ST, DA. So it allows you to filter by the masking characters on that job name. And if you have read access to the filter prefix command, ISF command.filter prefix, you can issue the prefix command and you can change what you see on those panels. You can, prefix asterisk, prefix kick asterisk, stuff like that. But if you don't have read access to that profile, you cannot issue the prefix command, which means you cannot change your current prefix, okay? Bear that in mind as we go forward. Same sort of thing for owner. So owner allows you to filter on the job owner for those jobs on those panels. Again, there's a SAF profile that covers the owner command, ISF command.filter.owner. If you don't have read access, you cannot issue the owner command. Output destinations. the dest command. So it allows filtering by destination using name values. Again, it applies to the JES2 queue displays only. Only users with authority to dest can change the defaults specified in the SDSF groups that they're assigned to. And again, you need read access to an SDSF class profile to do that. So you have this combination of prefix and owner and dest. And if a user does not have the authority to issue those commands, they can't change what their defaults are. So who decides what their defaults are? Well, that's actually done in your group definition. So ISF, PRM, XX keywords have got these three keywords, idest, owner, and prefix, and they dictate what the initial default settings are for each user in that group. Okay, so idest will just point to a list of destinations. It's an end table. But the owner will say, right, okay, owner none or user ID, and the prefix none, user ID or group. So if you want to restrict your general user guide that you can only see his own stuff, then you could say owner user ID, and he could never change out of that. He can't issue the owner command, he can't change it. That's all he will ever see on any of his queue panels. Okay. Some more advanced functions within the product. Cross-system data access. Okay, so if you are using SDSF in a sysplex on multiple systems, and you have authority to the sysname command, that allows you to see and gather data from more than one sysplex, in more than one system in the sysplex. And it'll obey the masking characters that's specified on your current sysname settings, that you use the asterisk and percent signs. What actually happens under the covers is this causes SDSF to send a message from the local SDSF server, SDSF Org server, to other SDSF Org servers in the sysplex. And all the responses are collated back on your local SDSF Org server address space, and then presented back to the client. And so we can see responses from all those systems. So in order to allow that, you need read access to an SDSF class profile called isf command.filter.sysname. And if the sysname authority is denied, then the data gathering request is restricted to your local system. Destination operator authority. Okay, so this goes back many, many years, and it was deemed that it's very impractical sometimes, depending on your circumstances, to have to permit your operations staff or systems programming staff to every JES spool class profile so they can view or more normally manage the output. Okay, so we provide this ability to define certain users with authority based on the destination for the output rather than the owner or the job name. And SDSF uses the term for this as destination operator. So to be a destination operator, the user ID must have read access to SDSF class profile isf-opper.dest.jes2 subsystem name, and author access if you want to do full management to the SDSF class profile isf-auth.dest.destination name. And if a user ID has access to alter access to that profile, he can do full management of all the outputs on that destination, regardless of their JES2, their JES spool class profile. Read access will just allow browse authority to that output. What actually happens under the covers is we populate what's called a network receiver user ID in the output JES browse token, and when the SAF authority check is performed by JES to the JES spool class, we use the receiver keyword on the rack group. So that's how we tell JES2 to use the receiver keyword, and it bypasses the JES spool check for those guys. It always allows it to go through. Foreign address-based data access. So there are some commands in SDSF that require cross-memory access to other address spaces that are not necessarily under SDSF or user control. So we might be looking at certain things within a foreign address space. A good example here would be the TCP structure, or the loaded modules, or the allocated DD names, things like that. So that is what we consider to be a foreign address space. It's not an SDSF server address space. It's not the client address space. It's some other address space. So the ability to do that is protected by a sequence of SDSF class profiles, where we construct an ISF job profile that includes the owner of if we can determine the owner of the address space, its job name, its sysname, and the type of access that we need, the type of thing that we need. And you typically need read access to that profile in order for the data gathering to occur. There are obviously some address spaces in the system that don't have an owner assigned to them. If we detect this, then we just use 8+ sites. And there's examples here of the sort of things that we use this for. So we've got the JDD action that you can do on DA and other displays, the JC action to show the loaded modules, the JT action that shows the TCP task structure. We've got JM and JMO that shows all the job memory and the job 64-bit memory objects. And in 2.5 we now have the MEM primary command to do storage browsing, general storage browsing. So this all uses the ISF job profiles to protect it. So you can do it on an individual owner or job name basis. Issuing operator commands. This is the generic issuing of operator commands using the slash rather than operator commands that we generate on your behalf for actions on rows. Okay. So in order to use slash, you need read access to isfopper.system. Now bear in mind, this only stops or permits users from issuing an operator command in SDSF. It does not stop you from running an in-house or other product style program that can do an operator command itself. SDSF does not own the ability to issue operator commands. That's owned by the BCP. Okay. So what we do with the slash command is we see if you're allowed to issue an operator command, and then we will just pass the freeform text that you issue straight to the BCP to say, okay, here's an attempted operator command, and we let the BCP do the operator command's authority checks itself. Okay. So you might sort of say, right, okay, I only want to allow someone to do this operator command if they are in SDSF. So it's sometimes, it's not desirable to allow users outside of SDSF to issue an operator command. So there is a simple solution. If you specify the when clause on your permit to the operator commands class profile, you can use a console name of SDSF. We actually, when we issue the operator command, we tell the BCP that the port of entry for this operator command is via SDSF, and we use that value, which means that you can control ability to issue the operator command based on whether the guy is actually in SDSF or not. And there's an example here that we are only allowing a JES2 cancel command to be issued by Fred if he's in SDSF. The when console clause is specified on that permit command. It does require the console class to be active, and the SDSF console defined as a profile within that class. Handling no decision situations, right? Okay, I mentioned this before on the old way that 2.4 used to operate, where it used to ask staff always to make a decision, and if the SAF product returned an 8, which meant that you couldn't do it, that was it, you didn't have access, or 0, you did have access. So 4 typically sort of means that it can't make a decision for some reason. It could well be that the class is not active, and a lot of people used to run with the SDSF class not active, so they always drop back with the return code for. The class may be active but not rack listed. That only applies obviously to rack F. The class is active and rack listed, but no matching profile was found. So there's no drop through. There's no asterisk profile within that class to give you a denied or allowed value. Okay. So what we do now in 2.5 is we will obey your directive that you specify in ISF PRM XX, and there's a keyword there called AUX-SAF. And possible settings are fail RC4 or no fail RC4. So if you've got fail RC4, we will treat any return code 4 from SAF as denied, and you have no fail RC4, we will treat any no decisions as allowed. Okay. So no fail RC4 can be quite a handy tool to use if you're doing migrations. Okay. So last section here is using SDSF to actually understand SDSF security. So in 2.5, we've added a few commands inside the product that report on the actual security metadata for the product as well, to help people along, because otherwise you've got to go and look in various manuals and tables and things like that. So there's a new command called Command H, CMDH, and that will list all of the primary commands within the product, and it will show you the class and resource that is checked for that panel. Okay, so you can easily see here which commands, what their panels are. When you see the lowercase text there, that's some sort of variable replacement. Certain commands don't have resources that protect them, and they'll show as blanks within the class and resource row. For example, help, we don't protect the help command. We don't protect the command H command, for example, and collH and things like that. There's also ActH, which gives you the similar sort of information, security information as the command H, but for actions on either the panel you're on or all panels. Okay, so you'll see here, this is where it gets a little bit more interesting, because you could be checking other class profiles. In this case, it's the operator commands profile for various things that we can do on this panel. And you can see here that these actions, sometimes they need read authority, sometimes they need alter authority to offer commands profiles, you know, the JES ones or the MDS ones. The collH command, one of the changes we got in 2.5 is collH used to be an ISPF dialog that was driven from some metadata that was in an ISPF table. It now is a proper SDSF panel, and it actually gets the running metadata from the executing product. So collH now includes the resource, class, and name for the overtypable columns on the panel as well. So you're seeing here, these are the overtypable columns on the ST panel. So we show the column, the internal column name, and the class and resource for what you need. So if you've got, it shows you the which columns are possibly overtypable on that panel. Security trace. Okay, so there is an internal SDSF security trace, which is independent of the other problem diagnostic trace that we supply. And this can be used to see all the SAF checks that are issued by SDSF. And the trace output is sent to your user session log by default. And you can activate it by a set command, set trace on, set trace off to turn it off. Or if you want, you can have set trace WTP, which issues WTOs instead of sending it to the ULOG. There are also some special DD names that we will look for, especially useful for tracing the initialization of the product. So ISF SecTR is equivalent to a SecTrace on, and ISF SecTW is equivalent to a SecTrace WTP. So if you want to track down your security checks made during the initialization of the product, use these special DD names. This is the sort of output that you will receive in ulog. And you can see here the checks that are being made against the various profiles and whether or not the access has been allowed. So it can be very handy for diagnosing problems. It can also be very handy if you're thinking about doing any sort of security migration, because you can actually track what's going on inside your current environment to see where you're getting a return code for. So any sort of return code flaws in your security trace output might indicate that there's something that you have to consider during migration. We also have an SDSF health check, and we've enhanced this for 2.4 and 2.5. So it's called SDSF class SDSF active. It's a health check, and this verifies if the SDSF class is active or not, but also the recent enhancements, it produces a report on all known SDSF resources and how the security decision will be derived, either by default or if SDSF is actually up by the definitions that the instance of that server has provided. For example, if the SDSF server is up, then we know we're in a fail RT4 or a no fail RT4 specification, so we can tailor that report based on the parameters that are running. Okay, so you will get one of three values for each of the profiles. You get SAF RC, meaning that the covering profile will be used depending on the SAF return code. Fail RT4 means that no covering profile was found and access will be denied due to fail RT4 in ISF PRM, and no fail RT4, which means it will be allowed due to no fail RT4 in ISF PRM. So here's an example now of the typical output from that health check. So on the left-hand side here is the start of the health check, and the report you go into browse on CK, and you see underneath there it produces this SAF class resource definition report with the decision, the access, and the resource set. We go through every single known resource that we have defined within our security tables to produce this. So again, it could be very, very handy for anyone thinking of migrating, just to make sure that you're going through here and you're not seeing any no fail RT4s or fail RT4s within this report. Okay, that's the end. I hope that's been okay. Open for any more questions.
Yeah, thank you very much for that, Rob. It was an excellent session. And just while hopefully people are going to put some questions in the chat, and we can unmute your lines, by the way, folks, if you want to ask Rob a question. In fact, I will do that now, so you can unmute if you want to throw a question to us. But it's quite interesting, isn't it, Rob? Sort of I mean, I'd have loved to have done a poll for this to sort of find out how many people are still using ICS Palms versus, you know, SAF. But I think it's quite clear now the clock is really ticking, isn't it, for these kind of internal security mechanisms?
That's right. Yeah. I mean, it's so 1980s, isn't it, to have your own
yes.
internal security table?
I was going to say that, and I thought, just yeah, but that is my immediate reaction. And I still know of sites, and I'm sure you do, that, you know, are still using these mechanisms, but times.
Yeah, one of the reasons that we actually authored this presentation is we've had a couple of conversations with early adopters of 2.5, and they had some fundamental questions about how the security operates, and I noticed some misunderstandings perhaps of what they thought SDSF was doing. I thought, oh, I better write a presentation about this because it's going to be a commonly asked question.
Yes. Good job you did. Okay, we've got a question from Stephen Butland. Hi, Stephen. He says, are the new commands and health checker available in 2.4 in preparation for moving to 2.5?
Yes. So we changed the architecture of the health check, and there's a PTF, I do believe. I can't remember the exact one, what it is as an API PTF, and it's been rolled back to 2.4. It hasn't been rolled back to 2.3 because the architectural changes that we require aren't there in 2.3, but they're there in 2.4 and it's there in 2.5. So you can use, if you're on 2.4, you can use that health check to help you migrate.
And Stephen says fantastic. So thanks for the question, Stephen. Any other questions? By the way, while we're waiting, if anybody else wants to put some more questions in, the feedback. So I'm aware at the moment, and I think, Sue, have we still got a problem with the website, conference website?
Yes, we do.
Yes. Okay. So there is an issue at the moment, but hopefully that will get resolved soon. So please do leave your feedback. This is session 5AB. Don't forget that the first question in that feedback, the best answer to give is 5, not 9. So please do that. And there's an incentive there, of course, for prizes as well. And as you, for those of you that have been to the conference before. And also don't forget our charity this year. So we're at 42% of our target at the moment, by the way, folks. So if you haven't donated already, please do consider giving a donation. When you can get to the website, you'll be able to click on any of the agenda items, and there's a Virgin Money Giving link there that will take you directly to their site where you can make your donation. And yes, as Rob has put up there a slide around becoming a member of GSE, so there are some really great benefits to becoming a member. I know many of the attendees on this call today are already GSE member companies, but there are the details there if you are interested. So it doesn't look like we've got any more questions, Rob. So all that remains me to say is thank you so much for taking the time. I always find this, like, I was working with a colleague last year that they were doing some security remediation work, and you can quite easily get yourself into a tangle, can't you, with sort of SDSF and console and JESPOL, and it's
Yep.
it requires some research, doesn't it?
It really does. And the one thing that obviously going to SAF in SDSF is one thing, but also having done the migration to JESPOL as well. So if customers can really be behind the 8 ball, if they haven't turned on the JESPOL class and they haven't turned on the SDSF class, they've got 2 migrations because they got the whole JESPOL migration as well. And that, you know, that's quite tricky. And funny enough, I was speaking to JES Development the other day, and I sort of said, you know, have you got any red books or guides for how you would actually do a JESPOL implementation? And I think they used to have something back in the 90s, but pretty much it boils down to you go on a test system, you activate the classing warning mode, you run it for a few minutes, you turn it off, and you go and see your results. You know, it is quite daunting. But if you've done the JESPOL migration, if JESPOL is active, the implementation of SDSF class profiles on top of that is much easier. You know, but if you haven't touched your JESPOL Opera commands or SDSF classes in the last 30 years, it is a migration effort. You know, it's not trivial.
Yeah. So there you go, folks. You've been warned. There's some research to do, and before you get to 2.5, but well worth sort of starting that path now, I would say, just to so you don't hit any glitches when you do get there. But no, thank you. Like I say, excellent session. So that's it for this session. We're back at midday. We've got a 30-minute break or 40-minute break now. We're back at midday on the security stream with Christian Karachi, and he's going to be talking about for forensics. So this is different. The session that he's giving is different from previous sessions that he's given, and he promises that there will be a surprise in there. So it'll be interesting to see what that is when we have that session. So please do join us for that. Like I said, when the conference website comes back up again, don't forget to leave your feedback, and we'll see you at midday. And Rob, thanks once again.
No problem.
Thank you. Bye.